Hello everybody, this is Naveen Sapare, Assistant Professor, Department of Mathematics, KLIT, Hubli. So in this class, we will continue of finding the Z transform of some standard functions, and also we study some properties of Z transforms. So we have a property if Z transform of Un is equal to U bar of Z, then first one, Z transform of k raised to n into Un is defined as the function of Z by k, and also Z transform of k raised to minus n into Un is defined as the function of Zk. Obviously, these properties we will derive it from the basic definition of Z transform. So, Z transform of Un is U bar of Z, then definitely we define the Z transform of k raised to n into Un. Un is obviously the given function, will be U bar of Z by k, and also Z transform of k raised to minus n into Un will be equal to U bar of Zk. And also we derived some standard functions, just I will take those here. Z transform of k raised to n is nothing but it is Z divided by Z minus k, so that is the first standard function. Later we derived Z transform of 1, that is Z divided by Z minus 1. Then we derived Z transform of n, that is Z divided by Z minus 1 the whole square. Then we derived Z transform of n square, and it is given as Z plus Z square divided by Z minus 1 the whole cube. And lastly we derived Z transform of n cube, that is nothing but Z cube plus 4Z square plus Z divided by Z minus 1 the whole raised to 4. So these are some standard functions, the Z transform of some standard functions we derived in the previous class. And also we have a property that Z transform of Un, if Z transform of Un is U bar of Z, then definitely Z transform of k raised to n into Un is given by U bar of Z by k, and also Z transform of k raised to minus n into Un is equal to U bar of Zk. So now we will solve some problems by using these properties. So that is Z transform of k raised to n into Un is equal to U bar of Z by k, as well as Z transform of k raised to minus n into Un is equal to U bar of Zk. So using these two properties we will solve some problem, and obviously we are going to find out the Z transform of some functions using these properties. So first one, find Z transform of k raised to n into n. So how to find out Z transform of k raised to n into n by using these two properties? Obviously we can compare this k raised to n into n with this function, that is k raised to n into Un. So in place of Un we are having n, and obviously according to the standard property Z transform of k raised to n into Un should be U bar of Z by k. So obviously to find the Z transform of the problem of the form k raised to n into Un, we always need Z transform of Un first. So here obviously Un is nothing but n. So every time while finding the Z transform of k raised to n into Un, the first step is to find out the Z transform of Un. Later in that answer we need to replace Z as Z by k. So let us take here Z transform of n. So already we are having a formula. If you don't have the formula, you just need to derive it once again. But already we are having a formula. Z transform of n is nothing but Z divided by Z minus 1 the whole square. So this is nothing but u bar of Z. Later, therefore, Z transform of k raised to n into n. Obviously, what we did in the first step, we just took this n separately and taken the Z transform of n. And the Z transform of n is Z divided by Z minus 1 the whole square. So now to find out Z transform of k raised to n into n, in this transform, we need to replace Z as Z minus k. So in place of Z, just replace Z as Z by k, and here also Z by k minus 1 the whole square. Now simplifying it further, so we have Z by k divided by, taking a LCM is k square, and here it becomes Z minus k the whole square. Obviously k cancel and 1k will remain here, that will come to the numerator, and it becomes Zk divided by Z minus k the whole square. So this is Z transform of k raised to n into n. Okay, very simple thing. You need to find out the Z transform of n. In that formula, you just need to replace Z as Z by k. So next one, we will take find the Z transform of k raised to n into n square. So as again the same procedure. First we need to find out Z transform of n square, comparing with this standard form k raised to n into un. Every time you need to find out the Z transform of un, and here un is nothing but n square. So taking Z transform of n square first, and already we know that Z transform of n square is nothing but Z plus Z square divided by Z minus 1 the whole cube. Obviously this is nothing but u bar of Z. After this step, we need to find out Z transform of k raised to n into n square. Definitely we need to compare this k raised to n into n square with this standard form, and obviously you are having u bar of Z here. In this u bar of Z, just we need to replace Z as Z by k to find Z transform of k raised to n into n square. Therefore, we have Z transform of k raised to n into n square will be obtained just by replacing Z as Z by k. So we have here Z by k plus Z square by k square whole divided by Z by k minus 1 the whole cube. Now simplifying it further, so LCM is k square. So when you take a LCM as a k square, so it becomes Zk, and this become only Z square whole divided by, taking a LCM in the denominator also, so it becomes k cube, and it becomes Z minus k the whole cube. Now this k square get cancelled, 1k will remain here, that 1k will come to the numerator. So it becomes Z into k square plus Z square k whole divided by Z minus 1 the whole cube. So this is nothing but Z transform of k raised to n into n square. In a similar fashion, we find Z transform of k raised to n into n cube. So again we compare this k raised to n into n cube with this k raised to n into un. Obviously un is nothing but n cube. So first finding Z transform of n cube. Since already we derived these all formulas, so directly we will take it. So Z transform of n cube is nothing but Z cube plus 4Z plus Z whole divided by Z minus 1 the whole raised to 4. So this is nothing but u bar of Z. Now to obtain z transform of k raised to n into n cube, we just replace z as z by k. So this become z cube become z cube by k cube plus 4 into z by k plus z by k whole divided by z by k minus 1 the whole raised to 4. So simplifying it further, LCM is again k cube in this number in the denominator, and here it is z cube will remain as it is, and here it is 4z k square plus z k square. Obviously it is z square here, so z square means this becomes z square and this is k square, and obviously here only zk will remain, and here it is zk square whole divided by k raised to 4 as it is, and it is z minus k the whole raised to 4. So obviously this k cube and this k cube cancel, 1k will remain here, that 1k will come to the numerator. Therefore we have finally k into z cube plus 4z into k square plus z into k cube whole divided by z minus k the whole raised to 4. So this is nothing but z transform of k raised to n into n cube. Now we will solve some problems on the property 2, that is z transform of k raised to minus n into un will be u bar of zk. Obviously this property, solving the problems by using this property will be very easy compared to the previous property. So k raised to minus un, that is z transform of k raised to minus n into un is given by u bar of z by k. So let us take the problem. Find the z transform of k raised to minus n into n. Just comparing this k raised to minus n into n with this property, that is k raised to minus n into un is u bar of z by k. Here un is nothing but n. In this property also, first we need to find z transform of un. Obviously un is nothing but here it is n, and since we know that z transform of n is nothing but z divided by z minus 1 the whole square. Later to find z transform of k raised to minus n into n will be obtained by just replacing z as zk. Therefore it becomes zk divided by zk minus 1 the whole square. There is no need of simplification. So definitely we got the z transform of k raised to minus n into n. It's very simple. Just you need to take un separately, find out the z transform of un, and later to find out the z transform of k raised to minus n into un, just replace z as zk. That's the procedure. So obviously this is nothing but it is u bar of z every time. So now taking the next function, finding the z transform of k raised to minus n into n square. Again same, you need to compare this k raised to minus n into n square with this standard form, and we know that un is nothing but n square. So taking z transform of n square, so z transform of n square is nothing but it is z plus z square divided by z minus 1 the whole cube, that is nothing but u bar of z. Later to find out z transform of k raised to minus n into n square, we just replace z as zk in this u bar of z. So we have kz plus k square z square whole divided by kz minus 1 the whole cube. So that is the z transform of k raised to minus n into n square. In a similar fashion, z transform of k raised to minus n into n cube. Once again, we will take z transform of n cube separately and find its z transform. So z transform of n cube is nothing but it is z cube plus 4z square plus z divided by z minus 1 the whole raised to 4, which is nothing but u bar of z. So now to obtain z transform of k raised to minus n into n cube, we just replace z as kz. So just replace z as kz in this u bar of z. So we have k cube z cube plus 4 times of k square z square plus kz whole divided by kz minus 1 the whole raised to 4. So this is the z transform of k raised to minus n into n cube. So in this video, I just explained you that the z transform of k raised to n into un and z transform of k raised to minus n into un solving